everyone. Today we'll be reviewing question 5 for the ratio test for convergence review worksheet. If you have any specific questions about the ratio test itself, that can be answered in a separate video. This question is kind of long, so bear with me and let's get through it. Identify the series for which the ratio test is inconclusive. Then name a different test you would use and explain why that test is appropriate for determining whether the series converges or diverges. So we have 3 series that we'll be dealing with today. We have the first one, the second one, and the third one. I'm going to go through each of them themselves and explain. So we know that the ratio test, we're trying to find the limit as n approaches infinity for the absolute value of a sub n plus 1 divided by a sub n. First, we want to identify a sub n and a sub n plus 1. Once we have done that, we are then going to utilize this here and substitute in those values, which we have seen here. After that, we have 2 fractions, one fraction on top being divided by another fraction on bottom. When you have a fraction divided by another fraction, you can rewrite it as taking the reciprocal of the bottom fraction and multiplying out to the first fraction. So that is done here. Once we have that done, we can look at our limit and see, okay, can we simplify anything? We have the 4 here and a 4 here that we can simplify. Now we want to take a look at our powers. We have n to the power of 8 on the top and n plus 1 to the power of 8 on the bottom. Both of our n's have a power of 8. That's going to be the highest power. Thus, when we have our numerator and our denominator have the same power for when we're taking a limit, that would just be 1. It would be our coefficient in front. So this here, our limit as n approaches infinity is approaching 1. And for the ratio test, when we approach 1, our results are inconclusive. Thus, when we're just looking at this here, when we're initially looking at the series, we can see that it's n to the power of 8, and we could move this 4 out. It doesn't affect us, where every term that we have, it's going to be 4 divided by n to the power of 8, and each n will be the thing that changes. So 4 is our constant. So instead of the ratio test, I would use the p-series test because it's in this form here, the p-series form, which is 1 over n to the power of p, p being some number, okay? And p in our case is 8. And for the p-series, when we have a number that is greater than 1, it means that the series is going to converge. Our next series we're dealing with is this one here. So we have the summation as n, when n equals 1 to infinity, for e to the power of n plus 1 divided by n minus 1 factorial. We have identified a sub n and a sub n plus 1. We're going to take the limit of a sub n plus 1 divided by a sub n. You can see that we drop these absolute value bars in the next step because everything will be positive, so there's no need for them. And then we expand some terms. So I expanded the e to the n plus 1 to be e to the n times e times e. And then I also simplified n plus 1 minus 1 factorial and made that n factorial. Then we can reduce some more and we say, okay, there's an e sub n here, or e to the power n here, e to the power of n here. There's an e here and an e here, thus giving us the limit as n approaches infinity with this. And we can take a look here. Here, and we have our, we can reduce more with our n factorial, our n minus 1 factorial, and our other n minus 1 factorial. So we can do that here and here. And then that leaves us with this here, the limit as n approaches infinity for e divided by n, which would be 0, and 0 is less than 1. Thus, the series converges with the ratio test. So we wouldn't have to figure out another test to utilize. Our last series that we're going to deal with is this one here, which is the summation as n equals 1 to infinity for 1 divided by uh, the square root of n. Here is our a sub n and our a sub n plus 1. We're going to now take the limit as of the absolute value of a sub n plus 1 divided by a sub n. And we do some calculations just to manipulate it into a nice looking form, which leads us to here. The power of both ends are the same. Thus, we are left with looking at the coefficients in front of them, and they're both 1. Thus, our limit approaches 1. And when we have a limit that approaches 1 for the ratio test, it is inconclusive. Um, I wouldn't even do the ratio test for this one. I would first look at the type of form we have, and I would have attempted the p-series because it's in the form of 1 divided by n to the power of p. In this case, our p power is this is 1/2. And for p-series, when we have a value that's less than 1, it means it diverges.